Well, now we're going to talk about the difference of two squares. So the difference of two squares is given by the formula. If you have like a squared minus b squared, okay, this is equal to a minus b in the bracket like that, open bracket, a plus b. Okay, sometimes it can be written as a plus b times a minus b, because multiplication is commutative. You know, if you have like 2 times 3, it's the same as 3 times 2. Now, I want you to note, it is important that there is no formula for the sum of two squares, okay? A squared plus b squared will still remain a squared plus b squared. There's no formula for that. Now, I just want to write it here. A squared minus b squared equals to a minus b, open brackets, a plus b. Or they can say a plus b like that, and then a minus b. Now, we have question 1 here that says x squared minus 16. So if we write the question 1 here, x squared minus 16. So the thing is like x squared is a square number already, okay? It's already a square number. And then 16 is also a square. I mean, x squared was a square variable, and 16 is already a square because it is a square of 4. Okay, it's like 4 squared. So this then we can say equal to open brackets x minus 4, close brackets, open brackets, x plus 4. Then we're done factorizing. And then I'll leave question 2 for you, and then I'll do question 3 here. And let's say question 3 now. This question there, we have like 9 x squared minus 4. Now we first look, is 9 a square number? Yes, it is. It is a square of the number 3. So it's like 3 squared, like 3 squared. And then that's x squared minus, is 4 a square number? Yes, it is. It is a square of 2. It's like 2 squared. Now, you know, this square is here, 3 squared, and then x squared can be written like this, all to the power of 2, because the exponents are common, okay? We can write 3x in the bracket like that to the power of 2 minus minus 2 squared. Now over here, we have a difference of 2 squares, okay? So we have like this 3x squared minus 2 squared, and then this will be then 3x minus 2, like that in the bracket, and then 3x plus 2. We can also say 3x plus 2 and then 3x minus 2. It doesn't matter. Okay. Let's take another example, question 4, for instance. Question 4 here, we have x squared minus 1. Now, as I said, x squared is a squared variable, so it's going to be still x squared there. And then 1 is also a square because it is a square of 1. So it's like 1 squared. And then in this case, what we do, this will be equal to x minus 1 and then x plus 1. See? So I'll leave question 5 for you to do because it's similar to question 3 we did earlier. I'll leave also question 6. Now let us do question 7. Okay, question 7. Now we're doing question 7 here. That is 100. Okay, x to the power of 8 minus y to the power of 6. Okay, so we can see that 100 is a square number. Okay, so I can write it like it's a square of 10. So it's same thing to say 10 to the power of 2. Now, note that x to the power of 8 Okay, this can be written as like this, to the power of 2. This can be written as x to the power of 4 to the power of 2, because the law of exponents in previous grades, you learn that if you have like a to the m raised to the n, this is equal to a to the m times n. Excuse me. M multiply by n. Okay, so x to the power of 8 here can be written as x to the 4 to the power of 2, because 4 times 2 here makes 8. So it's going to be x to the power of 8. Same thing. Now, minus, okay. The other one also, we can also put the power of 2, and then that's going to be like y to the power of 3, for the same reason as here, because this is going to be y to the power of 6. Now that the exponents here are common, we can write 10 x to the power of 4 all to the power of 2, no, and then minus excuse me, y to the power of 3 to the power of 2. Okay, and then now we have difference of two squares, because like 10x to the power of 4 all to the power of 2, this is a square because the power there is 2, and then y to the power of 3 to the power of 2, okay, because this is also a square. Then we can apply our formula for the difference of two squares. It's going to be like 10x to the 4 minus y to the 3, close bracket, open bracket, 10x to the 4 plus y to the 3, close bracket. Okay. Now we can do another example. We can do the same way we did 7. We can also do question 8. Okay. I think we need to do question 8 because it's a bit different. Question 8 says x to the power of 4 minus x squared. Well, one way of solving this is like previously. Remember, when we're doing highest common factor, so this one can be like x to the 2 times x to the 2. Okay, so now we can take one x squared as a common factor, and then this will be like x squared minus 1. Okay, and then after that we select the common factor. We can, this also another form of difference of two squares, because 1 can be written as 1 squared, 1 to the power of 2. Okay, so this will be like x minus 1, close bracket, like that, and then x plus 1 when we apply difference of two squares. Remember, those questions are meant to be solved fully, factorized fully. Okay. We can also do question 9. Question 9, is like 8 to the power of 4 minus 16. That was question 9. 8 to the power of 4 minus 16. Okay, so this will be we open bracket, like you can see a squared to the power of 2. Okay, and then minus 16 is something as a 4 squared, is a square of 4. So when we factorize this, it will be, okay, it will be a squared minus 4. Okay, and then a squared plus 4. So because here we have difference of two squares, a squared to the power of 2. This is a square because of this, and this is also a square because of that. And then we say a squared minus 4, a squared plus 4. And then we're done. We're not done, because here we can still expand this, okay? Because the variable a here is raised to the power of 2, is squared, and then 4 is also a square number. So we can continue factorizing this. This will be like a minus, because 4 is like 2 squared, okay, and then a squared plus 4 will remain the same, because remember we said there is no formula for sum of two squares. So it's going to be like that, and then over here it's going to be like a minus 2 in the bracket like that, and then a plus 2, and then a squared plus 4. Now we can say we fully factorize this expression. Okay. So if we really do like this, we really invite you to subscribe to the channel and then like the video and share the link to other students. Okay.